Welcome back. Let's study abstract classes. An abstract class cannot be instantiated on its own. It is a parent class. An abstract class contains abstract methods, which are declared but have no implementation. They are instantiated in child classes. So we can regard an abstract class as an immature class. We cannot create an object from an abstract class directly. This is the meaning of abstract class. This is the benefit or the privilege of the abstract class. Let's go back to our tree example again, and let's have a tree to be an abstract class, the parent class, and roots, trunk, branch, leaves. So let's start here. To create an abstract class, we must import a module ABC, abbreviation for abstract base class. So we have here from A, B, C, import capital ABC. And we must have another import here, which is abstract method. This ABC is a standard library module. It is a .py file. ABC here is the abstract base class. And we must import also abstract method. So we have our parent class here, the abstract class, class tree. And it's from the abstract base class ABC. Let's have our colon here, and let's define the constructor. And let's have an argument species here together with self. And let's define self.species equals species. Let's have our abstract method now. Before having the abstract method, we must have a decorator for it. So we have here the decorator, abstract method. And we start defining describe to describe the species of the tree. So we have describe, have our self between brackets and our colon, and we have a pause here. This means that children classes that will inherit from the abstract class tree will implement the method describe. But the abstract class tree cannot implement the method describe here. So let's have our first child class here, which is roots. So let's have class with a capital letter, roots, inherits from the abstract class tree. Let's define a method here. We define absorb water, which prints the roots of the self.species tree, absorb water and minerals from the soil. The roots of between placeholder self.species absorb minerals. Since the child roots inherits from the abstract tree, it must implement the abstract method describe. So let's have it here. Define describe self, and we print this is a self-species tree using the F string and between quotations. This is a placeholder self.species tree. Every child that inherits from tree must implement this describe, which wasn't implemented in the class tree because it is an abstract method. If we have more than one abstract method in tree, we must implement all of them in each child class. Let's go back to our main program here and start creating our first instance. So we have my tree equals, and we call the last generation class, which is roots here, and let's have the species to be, say, pine. The syntax here is the instance equals the last generation class with the arguments or the attribute of the base class, which is an abstract class in our case. Let's start calling the first method describe now. So my3.describe, and let's have a run. It gives this is a pine tree. It performs the describe method here. Let's try having my3 created from the abstract class tree. We expect an error because an abstract class cannot create an object. So let's have a run now. It gives error, can't instantiate abstract class tree without an implementation of an abstract method. Let's go back to our roots now. And let's call the method absorb water. So we have my3 dot absorb water and have our run. It gives the roots of the pine absorb minerals. Everything is going okay now. Let's have other children. So we have class trunk. So let's have a copy of this. And we have our class trunk inheriting from the abstract class tree. And let's define the method support. The trunk of the self.species supports branches and leaves. Of course, we must implement the abstract method describe again in the trunk class. Now, to have an instance that has the authority to call support, it must be created from trunk. It is the last generation of tree that can call support. So let's have another instance here. Say tree 1 equals, we call the class trunk, and let's have an apple tree. So this can call the method support. Let's have a run now. The trunk of the apple supports branches and leaves. That's what we exactly expected. We can even extend our example here to include grandchildren. So let's have another generation inheriting from trunk. Let's have a branch generation. So let's here have a copy, paste it here. Let's have branch, which inherits from trunk, and define the grow method. The branches of the self.species spread out to support the leaves. And let's have a further generation here, a class of leaves, which inherits from branch. And let's define photosynthesis with ourselves, of course. And let's have a print the leaves of this tree perform photosynthesis. Now going to tree 1, it must be created from the last generation class, which is leaf. Let's have my3 as comments now. And let's have our run. It gives the trunk of apple tree supports branches and leaves because it called the support method here of the trunk tree. Let's try to call the grow method and the photosynthesis method. So we have here tree 1 dot grow, and we have tree1 dot photosynthesis. Let's have our run to get the print expressing the job of each part of the tree. This concludes with our abstract class. You must start by from the module ABC import ABC abstract base class, and we have another import abstract method. The abstract class cannot create any instance. Abstract class contains abstract methods which must be instantiated in every child class which inherits from the abstract class here.